The universe is a tapestry of unimaginable vastness, woven with threads of light, matter, and mystery that stretch beyond the limits of human comprehension. In the transcript provided, we are taken on a journey from the familiar confines of our solar system to the farthest reaches of observable space, a narrative that captivates with its blend of scientific fact and poetic wonder. This part delves into the most compelling aspects of this cosmic exploration, highlighting how the content masterfully uses analogies, hierarchical progression, and inspirational language to make the incomprehensible feel accessible and profound. At the heart of the transcript's appeal is its ability to scale down the cosmos to human terms. Imagine sitting on a rock, our Earth, hurtling through space at 670,000 miles per hour, orbiting a nuclear furnace 1,000,000 times larger than itself. This opening sets the stage, transforming abstract astronomy into a visceral experience. The Milky Way, our galactic home, is described as a cityscape extending across the United States, then the Pacific, around the Earth, and multiplied by 6 billion. Such metaphors bridge the gap between everyday life and cosmic distances. A light year, equaling 6 trillion miles, becomes not just a number but a measure that makes the galaxy's 100,000 light-year span, 600,000 trillion miles, feel like a tangible expanse. This approach echoes the best of popular science writing, where complex ideas are demystified without losing their magic. The hierarchical structure of the narrative is another standout feature, building like a ladder from the local to the universal. We start within the Milky Way, a cosmic city with 400 billion stars, where we are embedded like a single cell in a massive organism. From our vantage 26,000 light-years from the center, we witness stellar nurseries birthing new suns and red giants exploding to seed heavy elements. This local theater expands to the Andromeda galaxy, our nearest major neighbor at 2.5 million light-years, racing toward us for a future merger dubbed Milky Way. The transcript vividly simulates this event. Gravitational dances reshaping spirals into ellipticals, our solar system flung to new orbits, yet surviving due to the vast emptiness between stars. Ascending further, we enter the Local Group, a family of over 50 galaxies spanning 10 million light-years, where the Milky Way cannibalizes dwarfs like the Magellanic Clouds through tidal stripping. This dynamic view portrays galaxies not as static islands, but as evolving entities in gravitational communities. The hierarchy climbs to galaxy clusters like Virgo, with 1,300 galaxies bound by dark matter, 10 times the mass of visible stars, evident in phenomena like the bullet cluster collision. Here, dark matter's ghostly passage through visible gas provides direct proof of invisible mass, a concept explained with clarity that demystifies one of astronomy's greatest puzzles. The pinnacle is the cosmic web, a foam-like network of filaments, walls, nodes, and voids spanning billions of light-years. Filaments channel matter like highways. Clusters form at intersections, and voids, 80% of the universe's volume, harbor near-perfect vacuums. The Boots void, 330 million light-years wide with fewer than 60 galaxies, evokes isolation. If we were there, other galaxies would be undetectable until modern telescopes. This web, mapped by surveys like Sloan Digital Sky Survey, reveals galaxies tracing bubble edges, a pattern born from Big Bang fluctuations amplified by inflation. Interwoven is the temporal dimension, light as a cosmic measuring stick. We see the galaxy as a patchwork of eras, nearby stars current, distant ones ancient. Andromeda's light left when hominids used stone tools. Cosmic microwave background shows the universe at 380,000 years old. This baby picture marks the observable edge at 93 billion light-years, expanded by cosmic stretching. The transcript's drama peaks with expansion exceeding light speed, not violating relativity, but space itself inflating, leading to dark energy's acceleration, doubling space every 10 billion years. These elements culminate in inspirational philosophy. Our galaxy is a grain of sand among 2 trillion, each with billions of stars outnumbering Earth's sand grains. Planets abound, suggesting life teams, yet distances enforce solitude. Humanity, forged from stellar nucleosynthesis, calcium from supernovae, iron from dying stars, becomes star stuff aware of itself. This echoes Sagan's sentiment, turning scale into significance. We glimpse truths across cosmic voids, witnessing strangeness beyond imagination. The transcript's strengths lie in this fusion: education through engagement, wonder through facts. It transforms data, like Hubble ultra-deep field's 10,000 galaxies in a sand-grain sky patch, into narratives that inspire. By humanizing the cosmos, it invites us to ponder our role, making astronomy not just informative but transformative. In an era of information overload, such content reminds us why we gaze upward, to feel connected to infinity. Now, let's turn our gaze to the stormier side of the cosmic sea, the debates, doubts, and outright controversies that swirl around narratives like the one in our transcript. While the previous part celebrated the awe-inspiring clarity of scaling the universe, this section dives into the murky waters where science meets speculation. What happens when bold claims about infinite multiverses or inevitable cosmic isolation rub up against the rigorous demands of evidence? We'll unpack the most contentious points, weaving in vivid real-world clashes from physicists' fiery exchanges, thought experiments that twist your mind, and the latest 2025 skirmishes that keep cosmology buzzing. Picture heated panels at conferences, Twitter feuds among Nobel laureates, and paradigm-shifting papers that challenge everything we thought we knew. Buckle up. This isn't just about facts. It's about the thrilling tug-of-war between wonder and skepticism that keeps cosmology alive and kicking. One of the transcript's flashpoints is its confident stride into speculative territory, treating ideas like eternal inflation and parallel universes as almost inevitable extensions of our reality. Picture this. The narrative declares our observable universe, 93 billion light-years wide, crammed with 2 trillion galaxies, as merely one small chamber in an infinite cosmic mansion. It's a jaw-dropping image, but here's the rub. These concepts stem from theoretical physics, not hard data. Eternal inflation, proposed by physicists like Andre Linde in the 1980s, suggests the Big Bang was just one bubble in an endlessly foaming sea of universes, each with potentially different laws of physics. The transcript leans into this, implying infinite duplicates of Earth and ourselves exist out there. But critics, including Nobel laureate Roger Penrose, argue this multiverse hypothesis is unfalsifiable, a fancy way of saying it's philosophy dressed as science. In a 2025 blog post for the American Philosophical Association, philosopher Eric Schwitzgebel vividly debated this, questioning if multiverses remove the need for a personal creator or just kick the can down an infinite road. Penrose, in interviews as recent as 2025's Science and Culture Symposium, slammed it as not even wrong, echoing Wolfgang Pauli's famous burn, because it can't be tested. How do you probe something beyond our cosmic horizon? If light can't reach us from these realms, as the transcript notes, we're left with mathematical elegance rather than empirical proof. To bring this controversy to life, imagine a packed auditorium at the 2025 American Physical Society meeting. On one side, multiverse proponents like Sean Carroll argue it's the cleanest fix for fine-tuning, why our constants allow life, citing quantum mechanics' many worlds interpretation. On the other, skeptics like Sabine Hossenfelder, in her updated 2025 edition of Lost in Math, counter with a rhetorical gut punch. It's a beautiful story, but without evidence, it's just fan fiction for physicists. Recent twists amp the drama. A May 2025 University of Oklahoma article linked supersymmetry to dark matter and multiverses, while Google's December 2024 Willow quantum chip sparked debates, echoed in 2025 forums, about simulating parallel realities. An August 2025 Medium piece by Ethan Siegel asked outright, "Are parallel universes real?" concluding they're compelling, but unproven. This sparks heated exchanges on platforms like Reddit's r/Physics, where users debate if multiverses violate Occam's razor, the principle favoring simpler explanations. The allure. It expands our minds. The controversy. It blurs the line between proven cosmology and frontier speculation, potentially eroding trust in science amid rising misinformation. Another hot-button issue is the transcript's pessimistic take on alien life and cosmic communication. It paints a picture of splendid isolation, where vast distances and light speed limits doom civilizations to cosmic solitude. Signals from the galaxy's far side would take millennia to arrive. And beyond our Hubble volume, 14 billion light-years, expansion outpaces any message. This echoes the Fermi paradox, where are all the aliens? But the narrative amps it up, suggesting the universe conspires to keep species apart. Engaging? Absolutely. It evokes a tragic romance of lonely worlds. But astrobiologists beg to differ, and the debates rage like a sci-fi showdown. In a June 2025 SETI Institute live event on Facebook, titled, "Could Aliens See Us?", experts tackled this head-on, with SETI's Jill Tarter arguing we're just scratching the surface. Our searches are like dipping a cup into the ocean and declaring no fish exist. Recent discoveries, like thousands of exoplanets from NASA's Kepler and TESS missions, suggest habitable worlds are common, perhaps billions in our galaxy alone, as the transcript admits. Yet it downplays optimistic scenarios. What about self-replicating probes? Von Neumann machines, traversing the galaxy in mere millions of years. Flash to a vivid 2025 debate at the International Astronautical Congress. Astrobiologist Sarah Walker clashed with pessimists, citing JWST's 2023 and ongoing 2025 detections of biosignatures like dimethyl sulfide on K218b as hints of life. The paradox isn't silence. It's our limited listening, she quipped, countering the transcript's gloom. On the flip side, a May 2025 astrobiology web paper quantified the paradox via passive SETI, using Bayesian stats to argue non-detections tighten bounds on alien tech. Centauri dreams. September 2025 post-SETI odds and ends fueled the fire, debating if the paradox dissolves if civilizations are rare or hidden. Twitter threads from Neil deGrasse Tyson amplify this. In one 2025 exchange, he pondered, Fermi asked, "Where is everybody? Maybe they're here, but we're not looking right." The controversy boils over. Is the transcript's isolation a realistic barrier, or does it overlook emerging fields like techno-signatures? JWST's findings challenge the solitude narrative, hinting at a busier cosmos and sparking optimism versus realism flame wars on forums. Then there's the transcript's handling of dark energy and cosmic fate, where it veers into doomsday drama with the Big Rip, expansion tearing atoms apart in 22 billion years. Dark energy, 68% of the universe, accelerates everything apart, leading to a shrinking observable sphere and eventual loneliness. It's a gripping tale, backed by the 1998 supernova observations that won a Nobel. But the controversy lies in the oversimplification, especially with 2025 twists. In April 2025, National Geographic article reported, DSI survey results suggesting dark energy evolves over time, potentially weakening and averting the rip, favoring heat death, a cold, empty fade-out. This echoes a June 2025 undark piece. The evolving debate around dark energy, where cosmologists like Adam Rees debated if it's constant, heat death assured, or variable, opening doors to Big Crunch. The transcript cites the Big Rip as a theoretical end, but its vivid language, tearing apart galaxies, star systems, and even atomic nuclei, could alarm readers unnecessarily. Envision a 2025 cosmology conference panel. Katie Mack from Big Think, in her May 2024 article, updated 2025, questions the fate if dark energy flips sign, leading to collapse. Pro-RIP advocates cite strengthening models, while heat death fans, per Wikipedia's entry, point to entropy's inexorable rise. A conversation article from 2015, still cited in 2025 debates, threw in cosmic consciousness as a wild card. But real fireworks came from a recent Facebook group post estimating collapse in 33 billion years if dark energy fades. This sparks ethical debates. Does popular science owe audiences nuance, or is exaggeration okay for engagement? In podcasts like The Joe Rogan Experience, guests debate whether such narratives foster fatalism or motivate space exploration. Philosophically, the transcript's oscillation between human diminishment, infinitesimally small, and empowerment, the universe becoming aware of itself, stirs controversy. It challenges anthropocentrism, echoing Copernicus's demotion of Earth, but risks nihilism. Why bother if we're specks in infinity? Religious thinkers might contest the materialist view, arguing for purpose beyond physics, as in the 2025 APA blog linking multiverses to creation debates. Yet, this duality engages. It mirrors discussions in books like Brian Greene's The Hidden Reality, where multiverses question uniqueness. The transcript's strength is provoking these questions, but critics say it lacks balance, glossing over uncertainties without sources. In the end, these controversies aren't flaws, they're the fuel of science. The transcript's bold strokes ignite curiosity, but they remind us, cosmology thrives on debate. As we ponder infinite hierarchies or silent skies, we're not just spectators, we're participants in unraveling reality's riddles. What if the real wonder is the argument itself? Imagine standing on a mountaintop at dawn, the universe's enormity sinking in, not as a weight, but as a call to action. From existential humility to bold exploration, the implications are as boundless as the cosmos itself. First, let's confront the elephant in the room, or rather, the speck in the galaxy, our infinitesimal size. The transcript hammers this home with metaphors like our galaxy as a single grain of sand on an infinite beach, amid 2 trillion others, each brimming with stars outnumbering Earth's sand grains. Philosophically, this echoes the Copernican revolution, dethroning humanity from cosmic centrality. But it goes further, suggesting in an infinite multiverse, every possible you exists elsewhere. This could trigger an existential crisis. If we're duplicates in endless realities, does individual life matter? Yet the narrative flips the script beautifully. We represent the universe becoming aware of itself. Made of star stuff, our atoms forged in ancient supernovae, we embody cosmic evolution. This echoes Sagan's sentiment, turning scale into significance. The iron in your blood traces back to stellar deaths billions of years ago. Philosophers like Alan Watts would nod. We're not separate from the universe, but expressions of it. In 2025's mindfulness apps and wellness trends, this idea resonates, turning cosmic scale into a tool for personal growth, reminding us that humility breeds empathy, reducing petty divisions on our shared rock. Socially, these implications could reshape how we tackle global challenges. Picture world leaders invoking cosmic perspective during climate summits. If Earth is one of billions of potential worlds, trashing it seems not just foolish but cosmically negligent. The transcript's emphasis on isolation, civilizations in splendid solitude due to light-speed barriers, highlights our uniqueness. With no guaranteed alien saviors, we're on our own to steward this planet. This fuels movements like effective altruism, where thinkers like Nick Bostrom, in his 2025 updated Superintelligence, argue for long-termism, prioritize humanity's survival to explore the stars. Controversies from Part 2 add nuance. If multiverses exist, our actions might echo infinitely, amplifying ethical stakes. Or if dark energy dooms us to heat death, why not live boldly now? In education, this narrative inspires curricula. NASA's 2025 Artemis missions, returning humans to the moon, tie directly to transcript themes, using JWST data to teach kids about habitable exoplanets. Schools could use VR simulations of galactic mergers, making abstract scales interactive and fostering a generation of cosmic citizens. Scientifically, the transcript's hierarchy, from local group to cosmic web, urges interdisciplinary leaps. Dark matter's dominance evidenced by the bullet cluster. implies 95% of reality is invisible, pushing physicists toward unified theories. In 2025, the Large Hadron Collider's upgrades hunt for dark particles, while Euclid Telescope maps the Webb's filaments, testing inflation models. The Big Rip versus heat death debate drives funding. If expansion accelerates, as DESI 2025 data suggests, we prioritize telescopes like the Giant Magellan to glimpse early universes before they redshift away. Controversies spark innovation. Multiverse skeptics demand testable predictions, leading to CMB anomaly hunts for bubble collisions. Astrobiology booms. JWST's 2025 biosignature detections on TRAPPIST-1 planets challenge isolation claims, prompting SETI upgrades. Imagine a 2030 breakthrough, detecting alien signals that see our galaxy as we see theirs, bridging the solitude. This could revolutionize tech. Quantum computing, inspired by string theory's dimensions, might crack faster than light puzzles, though relativity holds firm. Looking ahead, the transcript's golden age of visibility, our era seeing more galaxies than future ones, implies urgency. In 2 trillion years, only local group remnants remain visible, erasing Big Bang evidence. This cosmic amnesia warns. Document now. SpaceX's 2025 Starship tests aim for Mars colonization, extending humanity's reach before isolation bites. Philosophically, eternal inflation's infinite hierarchies suggest nested realities. Our universe and atom in a larger one, ad infinitum. This fractal view could inspire art. 2025 films like a sequel to Interstellar exploring multiverse ethics. Or AI simulations. Google's 2025 Willow chip models cosmic webs, blurring simulation hypothesis lines. Are we in a higher being's code? Yet, controversies temper hype. If untestable, focus on tangible benefits, like using cosmic data for climate modeling. Voids vacuums inform energy tech. Ultimately, the implications circle back to meaning. The transcript ends with, "The universe is stranger than we can imagine, and we are here to witness it." This empowers. Evolved from African plains hunters, we've mapped superclusters and heard black hole mergers via LIGO's 2025 upgrades. Our consciousness, perhaps emergent at multiple scales, makes us cosmic witnesses. In a polarized world, this unites. Religions reinterpret creation in multiverse terms, as in 2025 Vatican astronomy conferences. Psychologically, it combats despair. Studies in Nature Human Behavior, 2025, show stargazing reduces anxiety, fostering awe. Future outlook? By 2100, if we survive, interstellar probes might confirm exolife, rewriting isolation. Or discovering dark energy's secrets could avert the rip, enabling eternal exploration. In synthesizing, the transcript isn't just informative, it's transformative. Wonders inspire curiosity. Controversies hone critical thinking. Implications demand action. We're not lost specks, but active participants, turning cosmic vastness into purpose. As we gaze at the stars, remember, the universe stares back through us. As we stand on the precipice of cosmic understanding, the transcript's revelations propel us toward an exhilarating future where humanity might transcend its earthly bounds. With the James Webb Space Telescope's 2025 upgrades unveiling galaxies from the universe's dawn, we're entering an era of unprecedented discovery. Imagine, by 2040, AI-driven observatories like the Vera C. Rubin could map the cosmic web in real time, revealing dark matter's secrets through gravitational lensing data. This isn't sci-fi. It's the logical extension of the transcript's hierarchy, from our Milky Way to superclusters, pushing us to probe beyond the observable horizon. Controversies will fuel innovation. If multiverses remain untestable, as critics argue, we'll pivot to verifiable frontiers. Quantum telescopes detecting gravitational waves from the Big Bang's echoes, confirming inflation theories. Dark energy's acceleration, potentially leading to isolation, might inspire cosmic arc projects, self-sustaining habitats on exomoons, ensuring humanity's legacy against the Big Rip. Astrobiology thrives here. with biosignatures on Europa or Enceladus by 2035 via NASA's Dragonfly mission, the transcript's solitude narrative could shatter. Alien signals, perhaps via METI broadcasts, might bridge light-year gaps, turning Fermi's paradox into a galactic dialogue. Philosophically, this future redefines purpose. Infinite hierarchies suggest we're nodes in a fractal reality, our actions rippling through nested universes. Education evolves. Virtual reality sims let students walk Andromeda's arms, fostering global unity. Ethically, cosmic perspective demands stewardship, tackling climate change as if Earth is the only haven in our bubble. By 2100, fusion-powered starships could reach Alpha Centauri, carrying seeds of life, echoing stellar nucleosynthesis. Yet, challenges loom: resource wars over rare Earth metals for telescopes, or AI ethics in simulating realities. The transcript warns of amnesia in trillions of years, but our golden age empowers action now. Humanity, once plains hunters, now cosmic explorers. We're not specks. We're the spark. As the universe expands, so does our potential. Witness it, shape it, endure.